Welcome to physics class. Today we are going to discuss one important concept. In any triangle A, B, C, prove that A small a by sin A is equal to small b by sin B is equal to small c by sin capital C. Remember, this is small c, this is capital C. Please note down. Now, this is the question. Now solution. This is the question. Now we are going to solve the solution. Take a triangle Consider this is point A. This is point B. This is point capital C. For A, the opposite is small a. For C, the opposite is small c. For B, this is B. Consider like that. Now, here it is, this one is 180 minus B. This is 180 minus capital C. Obviously, this is 180 minus A. Now, take a triangle. Here, take in any triangle A plus B plus C is equal to 0. Therefore, A plus B is equal to minus C. Therefore, A plus B into C is equal to minus C into C, small c, both are small c. Therefore, A into C plus B into C, here A into C plus B into C is equal to minus C into C. Here A into C plus B into C is equal to 0. The rule is C cross C, A cross A, B cross B is equal to 0. Therefore, this A cross C we can write as minus C cross A plus B cross C is equal to 0. Therefore, minus C cross A is equal to minus B cross C. Therefore, C cross A is equal to B cross C. Minus minus cancel. Remember, A cross B is equal to minus B cross A. Similarly, B cross C is equal to minus C cross B. Formula. Similarly, C cross A is equal to minus A cross C. Formula. Okay. These three are important formulas. We have to remember according to vector equations. Now we got C cross A is equal to B cross C. Consider equation number 1. Similarly, A cross B is equal to B cross C. Equation number 2. From equation number 1 and 2, from equation number 1, comma 2, A cross B is equal to B cross C is equal to C cross A. Therefore, we also rewrite it as A cross B is equal to AB sine of 180 minus C, and also B cross C is equal to BC sine of 180 minus A, and also this is CA sine of 180 minus B. Reading this point, A cross B is equal to AB sine of 180 minus capital C, that is equal to B cross C is equal to BC sine of 180 minus capital A, that is equal to C cross A is equal to CA sine of 180 minus B. This is, we can also write as AB sine capital C is equal to BC sine of capital A is equal to CA sine of capital B. Now divide by divided by A, B, C. Therefore, sine capital C whole by C is equal to sine capital A by small a is equal to sine capital B by small b. Therefore, we also write as C by sine capital C is equal to A by sine A is equal to B by sine B. So, hence it is proved. Hence, it is proved. Now go to another question. What is parallelogram? What is parallelogram? Law of addition. Addition of vectors. Addition of vectors derived derive an expression derive an expression for the derive an expression for the magnitude and direction magnitude and direction of the resultant resultant vector using parallelogram law. Parallelogram law question mark. My dear students, once again I am repeating the question. Listen carefully. What is parallelogram law of addition of vectors? Derive an expression for the magnitude and direction of the resultant vector using parallelogram law. This is the question. Now go for answer. Now take here A, P. The vector name is P. Now take here A and D. The vector name is Q. These two are makes an angle theta. The angle between them is theta. Now take a parallelogram A, B, it is angle theta, it is vector Q, it is vector P, obviously it is also vector P. Now it is a resultant. It is a resultant. The resultant is R vector. It is a vector Q. Now I extend AB so that I draw a perpendicular to AB. The point name is, consider E. Here the angle is 90 degrees. Now here the angle is alpha. Now go for the definition. If two vectors are represented in magnitude and direction, by adjacent side of a parallelogram, drawn from a point, the diagonal passing through the same point represents the resultant both in magnitude and direction is called parallelogram law of vector. Now I am writing here definition. Listen carefully. Definition. If two vectors if two vectors are represented in magnitude and direction magnitude and direction by the adjacent sides of a parallelogram. Parallelogram drawn from a point the diagonal passing through that point represents their resultant both in magnitude and direction. Magnitude and direction. My dear students, once again I am repeating the definition. If two vectors are represented in magnitude and direction by the adjacent side of a parallelogram drawn from a point, the diagonal passing through the point represents their resultant both in magnitude and direction. This is about definition of parallelogram law of vector. Now we are going to discuss explanation or proof. P vector and proof. Vector P and vector Q are two vectors represented represented by AB vector and AD vector. Both vectors act at the common point A and mutually inclined at an angle theta. If the parallelogram A B C D is completed taking AB vector and vector AD as adjacent side. Sides. Then the diagonal vector AC represents both in magnitude and direction. My dear students, once again I am repeating, P vector and Q vector are two vectors represented by AB and AD. This is point number 1. Point number 2, both vectors act at the common point A and mutually inclined at an angle theta. Now point number 3, if the parallelogram ABCD is completed taking AB and AD vectors as adjacent side. Point number 4, then the diagonal AC vector represents both in magnitude and direction. Therefore, magnitude of resultant now magnitude of resultant, our side The line of action, the line of action, the line of action of P is extended. Is extended. The perpendicular the perpendicular the perpendicular drawn the perpendicular drawn from the perpendicular drawn from C meets the extension of the extension of AB at capital E. Now from figure it is obvious that BC is equal to AD is equal to Q vector, and angle CBE is equal to theta, and also AC vector is equal to vector R, and also once again I am repeating this point. The line of action of P is extended. The perpendicular drawn from C meets the extension of AB at E. From figure, it is obvious that BC is equal to AD, that is equal to Q vector. Therefore, angle CBE is equal to theta. Therefore, AC is equal to vector R. Now, AB vector is equal to DC vector, that is equal to vector P. Now, therefore, length of AB is equal to magnitude of P. Magnitude of P, that is equal to P. Similarly, length of BC is equal to magnitude of Q, magnitude of vector P, magnitude of vector Q, that is equal to Q. Similarly, length of AC is equal to magnitude of vector R, that is equal to R. Once again, I am repeating these 3 points. Length of AB is equal to magnitude of vector P, that is called P. Similarly, length of BC is equal to magnitude of vector Q, that is called Q. Length of AC is equal to magnitude of vector R, that is called R. Therefore, from triangle BCE sin theta is equal to EC whole by BC, that is equal to EC by Q. Therefore, EC is equal to Q sin theta. Consider this is equation number 1, and also cos theta is equal to BE by BC, that is equal to BE whole by Q. Therefore, BE is equal to Q cos theta, that is equation number 2. Once again I am repeating, cos theta is equal to BE by BC, that is equal to BE by Q. Therefore, BE is equal to Q cos theta, equation number 2. Now, from the triangle AEC AC whole square is equal to AE whole square plus EC whole square. Therefore, AC whole square is equal to AB plus BE whole square, that is equal plus EC whole square. Once again, AC whole square is equal to AE square plus EC whole square. Therefore, AC whole square is equal to what is AE? AE is equal to AB plus BE. Therefore, AB plus BE whole square plus EC whole square. Now, that is equal to AB whole square plus BE whole square plus 2 AB into BE plus EC whole square. Once again, AB square plus BE square plus 2 into AB into BE plus EC whole square. Now what is AC? R square. R square is equal to what is AB? P square plus what is BE? BE square is equal to Q square cos square theta plus 2 into what is AB? P. What is BE? Q cos theta. Q cos theta plus what is EC? Q square sin square theta. Once again I am repeating this point. R square is equal to P square Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. Now R square is equal to P square plus q square plus 2p q cos theta. Consider this is equation number 2. Now this is the magnitude of resultant. Now we are going to discuss about direction of resultant. Now direction of resultant. Now we are going to discuss about direction of resultant. The resultant makes the resultant makes an angle alpha with vector A. Say from triangle AEC, tan alpha is equal opposite side by adjacent side. My dear students, once again I am repeating the point. Listen carefully. The resultant makes an angle alpha with A. With A means A vector. Say from the triangle AEC, tan alpha is equal CE by AE. That is equal CE whole by what is AE? AE is equal AB plus BE. That is equal Q sin theta whole by P plus Q cos theta. Therefore, tan alpha is equal Q sin theta whole by P plus Q cos theta. Consider this is equation number 4. Therefore, alpha is equal tan inverse Q sin theta whole by P plus Q cos theta. Consider equation number 5. This alpha is the direction of resultant. In the parallelogram law of vector, we discuss two side definitions. One is magnitude of resultant and direction of resultant. So this is about parallelogram law of vector. My dear students, I hope you understood this video. Thank you very much for watching this video. Thank you.